Welcome back. Section 2, we're going to look at circles. So I know in the first section we had a little bit of everything. Today we're going to just focus on circles. We're not going to worry about the ellipses and hyperbolas and parabolas, nothing like that. So we are going to look at equations of circles. We're going to look at how to write them, how to graph them, although how to graph it is not that tough. And we'll be looking at equations of tangent lines to circles even. So lots of fun stuff in store. Our learning targets for today: I can write an equation for a circle, and then I can graph a circle and identify its center and radius. Again, circles, you've dealt with circles before. In fact, you know what a circle is. So this, what is a circle, kind of seems strange. But we're going to start out with the definition of a circle. And you might think, you know the definition of a circle, it's a round thing. Well, yes and no, it has a better definition. The definition of a circle is all points equidistant from a center point. We're going to get the definition of all four of our conic sections and see how they're similar and different. But right now, just circles, all points equidistant from a center point. We have a couple different equations. The first one is just where it's centered at 0, 0. So it's all points equidistant from the center. We have a center, then we have the radius here, and that would go around as the same no matter where on the circle we are. The equation for this is just x squared plus y squared equals r squared, where x and y are variables, and r is the radius. Well, what if we took the center and we moved it to another point? Let's say to the point h comma k. Oh, the h comma k is back. What does h comma k remind you of? If you're thinking transformations, you would be correct. We just shifted the center to h comma k. So if we started out with x squared plus y squared, well, x, we moved it over h, that just becomes x minus h squared. And then usually with the y, we would add k just to the end of the function, but we don't have a function. We do the same thing with the k that we would do with the h. So we're going to get x minus h squared plus y minus k squared. And we'll actually see how we've really been doing this all along a bit later. We're not going to look at that today yet. But this is our more general form for the equation of a circle. X minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. And so, how are we going to use it? Well, let's get our equations up here so we can see them. What if we have a center at 6, negative 5, and a radius r equals 4? Let's write the equation for the circle. So this one we only use when the center is at 0, 0. It's not at 0, 0, so we're going to use this one. Most of the time you'll probably be using this one, especially with circles. So the center is 6, so we'll have x minus 6 squared, and y minus negative 5 squared equals, radius is 4, so we'll have 4 squared. We can simplify this a little bit. Y minus negative 5 is just going to be y plus 5. 4 squared is 16. And so we have x minus 6 squared plus y plus 5 squared equals 16. This is where I'd leave it. Don't distribute this out, because first of all, x minus 6 squared is not x squared minus 36. You need the minus 12x in there, then it would be plus 36. And then same thing with the y's. And then it just gets big and complicated. This is standard form. It's where we can see the center and the radius, and it's all nice. Later on in the chapter, we're going to be going from that giant equation back to this equation, but again, that's not quite yet. And so if we're given a center and radius, we just plug them into the formula, and we have our circle. What if we have a graph? Well, isn't giving us a graph the same as giving us the center and the radius. If we look here, first of all, looking at the graph, notice that this is 8, which means that each of the lines is 2, not 1. And so our center is at 3, 0, and our radius, we went up 1, 2, 3, so that would be 6. Went over this way 6, backwards 6, down 6, and so the radius is 6. So we have a center at 3, 0, radius 6. We do the same thing that we just did here. Plug in our center, so we'll have x minus 3 plus squared plus y minus 0 squared equals 6 squared. And then simplify. 6 squared is 36. And since this y is all by itself, you don't need the parentheses. The parentheses aren't wrong, but you can take them away if you would like. Then we get x minus 3 squared plus y squared equals 36. There's the equation. We just plug the center and the radius in. What if they give us a center and it contains a point? Well, here we have the center. That'll go there. We just need a radius. Isn't the radius the distance from the center to the point? The distance formula, we used that yesterday. Or, let's plug in what we know so far. We know the center. So x minus negative 1 is x plus 1 squared plus y minus 9 squared equals r squared. We can plug the point, 2, 5, right into our equation. It's xy. And then we can get r squared. So now, what if we took the square root of both sides here, so it equaled r? Isn't that just the distance formula? The distance equals the square root of x minus x squared plus y minus y squared. The equation for a circle is the distance formula. That's really all it is. And the distance formula is Pythagorean theorem. And so the equation of a circle is Pythagorean theorem. Almost. We still have to have our x minus h and y minus k. But doesn't this, where it's centered at 0, 0, x squared plus y squared equals r squared, a squared plus b squared equals c squared? It's Pythagorean theorem right there. But it's Pythagorean theorem and distance formula. That's all this is, because a circle is all points that are equidistant from a central point. And so the distance is part of the definition, so it makes sense it's the equation. Anyway, back to our problem. So we could just use the distance formula to find this distance, or plug it in. 2 plus 1 is 3. 5 minus 9 is negative 4. So 3 squared plus negative 4 squared equals r squared. 3 squared is 9. Negative 4 squared 16. 9 plus 16 equals 25 equals r squared. And so we could say, oh, so the radius is 5. That's great. What if this added together to get 20? Radius isn't quite as easy to find out, but is it asking about the radius? No, we want r squared. We're just going to take this number, r squared equals 25, and put it back up here in the first step where we have our equation. So we'll just replace the r squared. So we get x squared, or x plus 1 squared, plus y minus 9 squared equals the 25 that we just found. And there's the equation. This one definitely takes the most work because you actually have to find the radius, where these guys, it just gives you exactly what you need. Another thing it could do, those questions where it gave you the endpoints of the diameter and you had to find the center and the radius, you could have to take the center and radius and plug that into the equation for a circle as well. So there's not a lot going on with circles because there's really just two things. There's the center and the radius. Those are the only things defining a circle. So you can't do a lot with them. But we can find lines tangent to a circle at a certain point. The questions here will look something like, write the equation of the line that is tangent to the circle at the given point, and then it'll give you the equation of a circle and a point. And so what's going on here? If we graph this circle, notice the center is at -6, -4, and the radius is 5. So we can graph the circle, And then we can make a tangent line at the point -9, -8. So at about -9, -8, it should be closer to here, but it's close enough. We get the idea. We're going to find the equation of this line. Now, a couple things to point out that'll be a review from geometry. We have the radius and the tangent line, as is notated on this diagram, are perpendicular. And so, if we can find the slope of this radius, we can figure out the slope of the tangent line. What do we need in order to find the equation of a line? We need a slope, and we need a point. The point is this point right here. So, let's find the slope of the radius first. Slope of the radius is just y minus y over x minus x. We have a center, and we have the point. Remember, the center is -6, comma -4. And so y minus y will be -4 minus -8. X minus x is -6 minus -9. Minus negative is just plus. -4 plus 8 is 4. -6 plus 9 is 3. And so the slope of the radius is 4/3. Well, if the tangent line is perpendicular to the radius, what do we know about the slope of the tangent? Perpendicular slopes are opposite reciprocals. So since this is 4/3, the slope of the tangent will be -3/4. We make it negative, and we flip the fraction. So now we have a slope, and we have a point. We can find the equation of the line. I recommend using point-slope form. Oh, there's our point. Point-slope form, y minus the y point equals slope times x minus the x point. We can plug in our point, -9, -8, so y minus -8, x minus -9, and the slope, -3/4, goes in for m. Then we can simplify this. Minus negatives are just plus. Now we're going to distribute the -3/4 to get -3/4 x, and then minus 27/4. You can leave that as a fraction, or in this case, since the next step is going to be to subtract 8, maybe make this a mixed number. So 27/4 is going to be 6 3/4. So we have -3/4 minus 6 3/4. Subtract 8 to get y equals -3/4 x minus 14 3/4. So this line down here looks like it might hit -14 3/4, about -15. Let's see, 5, 10, about -15. So makes sense. Slope's negative. Again, makes sense. One thing and so this is the end of this answer. The end of this is the slope of the tangent line at that point. One thing I wanted to point out though is the point slope form of the equation. This should look a little bit familiar. I know we've done point slope, but that's not what I mean. Let's change our variables. Instead of y1 and x1, having those subscripts, the 1, can get kind of confusing. So let's change them just to other letters. Let's change them to H and K. So here, this shows that this form of the equation of a line is really just a transformation. It's a translation of y equals mx. In fact, m, the slope, is a vertical stretch or compression. But the minus h, then usually we'd have plus k, but we have it subtracted over here. Minus k. We have y minus k and x minus h, which, if we remember the equation of the circle, x minus h and y minus k, we're going to see this with every conic section that we're doing, because it's been the same. We just have always added the k over. So anyway, this isn't necessary right now. Since we were working with this though, I just wanted to point that out to you. Anyway, again, this is the answer. This is the equation of tangent line and the point. We found the slope of the radius using the center and the point. Opposite reciprocal is the slope of the tangent plus the point. We can plug it into our equation to get the equation of the tangent line. Other than that, we're writing equations given information. Graphing a circle, you start out with your center, then go the radius in the 4 basic directions, and then sketch it as best as you can. I understand not everybody is an artist, but it should look roughly circular. It should not look like a square turned on its side. But anyway, lots of circles. And with that, I will see you in class. Don't forget to leave a comment.